Why are your Docker containers getting OOM killed? Imagine running a busy kitchen where each chef is a container. If one chef uses too many ingredients, the pantry runs out and the whole kitchen stalls. That's similar to what happens when Docker containers get OOM killed. Docker containers can be like those chefs. They run applications that need memory to work. But if they demand more memory than the host system has or what's set for them, trouble begins. The Linux kernel, which manages memory on the host, has a safety feature called the out-of-memory killer. It steps in when memory runs low and starts shutting down processes to keep the system stable. By default, Docker containers don't have specific memory limits. That means they can use as much memory as the host allows. If a container's workload demands more memory than the host can give, the kernel notices and kills the container process. This prevents the entire system from crashing but causes the container to disappear unexpectedly. The Linux kernel's out-of-memory killer doesn't target processes randomly. It assigns scores to processes based on how much memory they use and how important they are. Containers don't have special priorities, so they're often among the first to be killed when memory is tight. This is why setting explicit memory limits on containers is so important. Using flags like memory and memory swap in Docker commands helps control how much memory and swap space a container can use. Memory leaks are another common cause. If an application inside a container keeps consuming more memory without releasing it, the container's memory usage grows unchecked. Over time, this can trigger an OOMKilled. Monitoring containers regularly can catch leaks early, so you can restart or fix the application before it causes problems. Sometimes, the host system itself is under pressure. If the host runs out of memory because too many containers are running or because of kernel bugs, the kernel might kill containers to free up resources. Adjusting kernel parameters or adding swap space can help manage this better. Swap acts as an overflow area for memory. If swap is not configured or is too small, the kernel has fewer options to free memory, increasing the chance of a container being killed. In cloud environments like Amazon Web Services, Microsoft Azure, or Google Cloud, resource limits are often in place. Setting proper memory limits on containers prevents exceeding these quotas and helps control costs. Using container orchestration tools like Kubernetes makes it easier to enforce memory limits and automatically restart containers if they get killed. Monitoring tools integrated with cloud platforms can alert you to memory spikes or leaks early. Optimizing application memory usage inside containers is also key. Avoid memory leaks by fixing bugs and managing resources efficiently. Properly tuning host kernel parameters and ensuring enough swap space are additional steps to prevent unexpected kills. Testing your container workloads under realistic memory conditions before deploying helps you understand their needs and set appropriate limits. In the end, Docker containers get OOM killed because they push beyond available or configured memory. Setting clear limits, monitoring usage, tuning the host system, and managing swap space are all ways to keep your containers running smoothly. These practices help keep your applications stable and your infrastructure reliable.